Hello. Let's look at using the root test. Now, you might recognize these problems from our classwork. What I'm going to do is go through some of these problems with series. And using the root test, I'll determine whether or not they converge. The first series I want to look at is the sum, n starting at 1, going to infinity, where my sum ends take the formula, the fraction 2n squared plus 1, all divided by n squared, raised to the power n. So there's a series. In the root test, I want to calculate a limit. In the limit, n will be going to infinity. And the formula that I use for this limit, I'll take the nth root of the absolute value of my sum end formula. So nth root of the absolute value of 2n squared plus 1, all divided by n squared. Sorry about the mouse handwriting. These absolute values are important just in case I end up with a negative number. Negative numbers do not have square roots. They don't have fourth roots. They don't have sixth roots. Any even-powered root of a negative number does not produce a real number. It's redundant in this problem because this fraction will always produce a positive number, but it's important to remember. Now, what's going to happen here, I'll simplify the formula that I see in my limit, but I am still working inside of a limit. As I was saying before, the fraction is always going to be a positive number, and I'm going to go ahead and write that fraction a little more simply. I will say this is the number 2 plus the fraction 1 over n squared. I have split my fraction where I see addition in the numerator. 2n squared on n squared is just 2. Since this is always positive, the absolute values are redundant. I'll go ahead and write this with the 1 over n power. So what's happening in this limit, I'm taking the fraction 2 plus 1 over n squared and raising it to the power 1 over n. So this is always going to give me a number slightly larger than 2, right? 2 plus a very small fraction. And then I'm taking the nth root of that number. So what this is going to give me is the number 1.